I know lifting a car up with a bobcat and working underneath it is not the safest thing in the world, but then neither is driving a car or a motorcycle or hang gliders. But I'm going to take the chance anyway, because I've lifted many things with this machine and held them up for long periods of time that were a lot heavier than this little car. What I'm going to try to do is gas weld this muffler back on there. What I'm going to weld with is just a regular cutting torch. I'm going to take the torch head off and put a gas welding tip on it. Just screws in the same place. And I'm going to wear some dark safety glasses. These are really dark. They might be too dark. Let me get the camera back up, and of course I'm not telling anyone to raise up their car with a bobcat or a tractor of any kind and work on it under there, but it's the only way I'm going to get the video done, and I wouldn't do it if I really thought it was a serious risk of it coming down. It's really not that big of a risk. It's a lot more dangerous to do, like I said, some of the other sporting things that people do. How these kids jump on those small motorcycles and spin flips in the air. YouTube's full of that, so I'm not telling anybody to do it this way. I'm just showing how to gas weld, and that's how I'm gonna be able to get the camera on it. Okay, got it welded up. Not a very neat job, but then when it's all rust, super thin, nothing but rust, you can't MIG weld it, so the torch weld is the only way to do it. And that's a temporary patch, but we'll get by. Something to last for a little while. I just welded a muffler back together on my little run-around car, and wasn't able to get very good video on it. So I'm going to do a couple pieces of scrap metal here, stick them together just to explain better how to gas weld. Just regular cutting torch. I can't see the thing on the camera. I don't have my monitor set up out here. Just a regular cutting torch that you take off and then screw a welding tip on there. It's got to be tight. It's got a couple of O-rings in there that will seal it. I'm wearing these dark safety glasses. Just any decent dark sunglasses are really good enough. So you gotta, and I'm gonna use coat hanger wire. So take my glasses back off until I'm ready to weld so I can see what I'm doing, so I can see the monitor on the camera. Yeah, just coat hanger wire, and then we gotta fire this thing up and get a neutral flame. I don't know if I'll be able to see that or not. I may have to do that on another video inside to see what a neutral flame looks like. So my gas pressure is around 10 on the oxygen, 10 on the acetylene. I usually run around 10 on the acetylene and 20 on the oxygen, because it's usually cutting or preheating stuff to bend it. So I'm going to turn just a little bit of oxygen on and a little bit of acetylene, fire it up. There's a gap between the flame and the tip, so we got to turn the oxygen down just a bit, and the acetylene, so the acetylene is on the tip like it is there. Turn it back up a little, just a little bit. Turn the oxygen up just a little. Keep turning it up. I don't want that much. I'm going to turn the acetylene back down. It's probably a little more than I want there. Turn the oxygen back down a little bit. Turn the acetylene back down. Okay, that's a neutral flame. Gosh, I hope we can see that in there. So when this blue cone, there's going to be two blue cones when you have a carbonizing flame, it's a little bit too much acetylene. That's when you have two cones, an orange cone that's around the blue cone. Well, you want to turn your acetylene back down until it meets, the orange cone meets even with the blue cone, and they're both the same like that. That little glowing spot there is a little carbon ember. We'll just knock that off of there. That's a neutral flame. And what we're going to do is, let me see if I can see where we're at here, get a close-up. When these two pieces are touching together, we can do what they call just puddling. That's without adding wire. That's just heat both sides back and forth evenly until you see a shiny orange puddle that comes together, brings the two together, melting them together. Metal has to be thick enough to do that. If it's too thin, it won't do that. It'll just melt away. You have to add to it. And you do it at an angle, about a 45-degree angle, as much as you can get away with it. If you can't, then you can't, but that's what you try to go for. When you got a puddle going, now you can add metal to it. I think I do want a little bit more heat. Turn it up a little bit. I was welding real thin stuff on my muffler, so I had to turn it down quite a bit for that. Now we can just chase that puddle all the way down, just like I'm doing right now. But I'm going to go on ahead and add metal to it. Well, let's just puddle it for a minute. If we got a gap coming up, we'll add metal to that one. Make sure it's melting in on both sides. And that is just typical gas welding. It takes the temper out of the metal, when electric welding actually adds temper to it because it superheats it, and then the metal sucks the heat out faster and it tempers it. Well, this heats it up slowly, which causes it to lose temper. But there are applications where this is the only way you can do it. So I don't know how well we can see it. Let me hold the camera in my hand. This first part here is where we just puddled it. didn't add any metal to it. And then when we started adding metal over here, it got thicker. So there you go, just basic gas welding.